Hello YouTube, this is our fifth video. We quickly want to give our reasons for why canonical or traditional long division is a bad format. Our reasons will come from a single idea. That idea is the concept of compactness. Compactness for us is a presentation flaw where too much information in too small of a space or area is presented to a problem solver. The density of information tends to make the problem solving and error inspection processes unnecessarily difficult. We want to display our idea of compactness via a sample division problem. This problem consists of a single cycle of division in a placeholder and the creation of a new sub-dividend. If these terms are unfamiliar to you, please view video 4 about the traditional long division processes. In our problem, we determined that the sub-dividend 188 has 5 quantity or groups of 32. 5 is our sub-quotient for the 100s placeholder. You can see on the whiteboard where we write our sub-quotient. Please note that we obtained our 5 depending upon the problem solver's interpretation via addition, multiplication, or division. These operations are equivalent in our process to find the sub-quotient. We next multiply our sub-quotient 5 by the divisor 32 to get a product of 160. Our product of 160 involves the operation of multiplication, and you can see its location on the whiteboard. Our product of 160 will be used to find the indivisible by 32 part of our sub-dividend 188. Subtracting 160 from 188 gives us the indivisible by 32 or not evenly divisible by 32 part of our sub-dividend 188. This process introduces another arithmetic operation, subtraction, and more information to our problem-solving area. Our difference is 28, and you can see its location on the whiteboard. Our last step in this single division cycle is to create our new sub-dividend. We perform this step using the arrow to bring down the next number in our dividend. Our next number is 4, and you can see its location on our whiteboard. The arrow and the appending of the 4 to the difference of 28 represent two separate operations, multiplication and addition. The 28 is multiplied by 10 to obtain 280. Also, the 280 is added to the 4 from the tens placeholder to obtain our new sub-dividend of 280 plus 4, or 284. This completes our single division cycle. If we view our whiteboard, perhaps the viewer will agree with us that this format of division is too compact. There is too much information in too small of an area of the problem. Our single division cycle involves 4 basic arithmetic operations: addition, subtraction, multiplication, and division. These operations occurred in our subprocesses and in multiple locations in the problem. If our problem only has a single division cycle, say 48 divided by 24, then this amount of information in a small area may not be as much of an issue for the problem solver. However, unfortunately for us, nearly all division problems we encounter have multiple division cycles. Our sample problem on the whiteboard, depending upon how the problem is solved, contains 3 to 5 division cycles. It seems highly likely that this repetition of dense information causes interpretation and execution errors for many problem solvers. We hope the viewer now understands our perception that traditional long division is a bad format or means of visual presentation for division. If you go to the website at the top of our whiteboard, arithmetichelp.com, we offer an ebook. Additionally, we also offer a free sample download of our ebook. This free sample download contains approximately 75 pages and 60 pages of instruction. Thank you for your time. Have a great day, YouTube.